So let's make a review about building a simple neural network with PyTorch. Uh, in the lab, we introduces the fundamentals of neural networks by guiding the learners through the complete machine learning pipeline using a simple real-world delivery scenario. The goal is to predict delivery time based on distance and make data-driven decision using a single neural network built with PyTorch. Okay, number one, the problem overview. The task similar to bike delivery job where arriving late could have serious consequences using historical delivery data, distance versus time. The learner trains a neural network to decide whether a 7-mile delivery can be completed within 30 minutes. This practical framing helps connect abstract machine learning concept to real-life decision making. Machine learning pipeline in action. Data ingestion and preparation. Input data consists of distances, miles, and delivery times in minutes. Data is already cleaned and converted into PyTorch tensors with float 32 precision. Although simple, this step reinforces the importance of proper data formatting. So the model building. The model is intentionally minimal, a single linear neuron implemented using the NN linear 1 represents the equation of time is equivalent to weight times distance plus bias. It's like this mirrors like a linear regression, helping learners to see how traditional statistical model relate to neural network. The training process. Training is done using loss function, mean squared error, and optimizer, stochastic gradient descent. Okay. Learning rate, we set it at 0.01. Epoch of 500. Of how many? Epoch is something like how many iteration inside the model will do, right? The last function is something like how what is the percentage or how low the error rate of our model, and the optimizer is the one who could uh, make the error rate less as possible. Key training concepts reinforce forward pass, loss computation, backpropagation, gradient updates. The steadily decreasing loss confirms that the model is learning effectively. Visualization interpretation. Plot compares actual delivery data points, the learned prediction line. This visual validation makes it easy to confirm that the model captured a reasonable linear trend, prediction, and decision making. When predicting a 7-mile delivery, the model outputs approximately 37.1 minutes. Based on this, the decision we should not take the job because 7 miles could lead to 37 minutes. This, this demonstrates how the machine learning model support real world decision that this generate happens. Inspect learned parameters. The trained model learned weight is equal 5. Each traditional mile adds 5 minutes. Bias. The fixed overhead time pick up preparation like that. Model failure and complex data. When tested in a new dataset, mixing bike and car deliveries, the loss increases dramatically visually in assurance job pattern. The linear model fails to fit curve, real-world behavior. This clearly demonstrates key limitation. Linear models can only learn straight line relationship. Okay. So our key takeaways is a single neuron can effectively model simple linear relationships. The model pipeline data model training prediction is foundational. Baka nandun sa kabilang kwarto. Wala, di ko naman nakita. Baka nandun sa kabilang kwarto. So, robustness, model failure. Conclusion. This lab successfully builds intuition for how neural networks learn, how predictions are made, and why model complexity matters. By intentionally exposing the limitations of a linear model, it sets a strong foundation for future lessons, then layers activation functions and nonlinear learning.